All right, we're back. We're on page 1 of notes 12 of Calc AB, and we're going to talk about something called definite integrals, and we're going to deal with those graphically. And so, I don't know, do we know what any of that means? Maybe. So definite integrals are just the accumulation of rates of change. But what are rates of change? They're usually the derivative of something. So it's kind of like we're trying to figure out like what the total impact of a derivative is over a certain time period. This is all like a very general sense of what it is. Let's actually do this page and see if we can start to make more sense of what it is that I am talking about. So I'm going to start with a really old idea for most of us, and it's the fact that rate times time equals total, right? So distance equals rate times time. If you make $5 an hour and you work for 10 hours, you make 5 times 10, $50 in that amount of time. Rate times time equals total. This is one of the most basic ideas that you run into. I think you probably run into it in 6th grade, maybe before that. But it turns out we're going to be able to do a lot of calculus using that idea, and that's kind of weird. So let's see what I mean by that. So each of the graphs below represents the velocity. So velocity is a really common rate that you will deal with. So the velocity in feet per second, where units are like crazy important in these sorts of things. So units matter a lot, of a particle that's moving along a horizontal axis over a certain time period. So it's moving on like basically the x-axis. So we're looking at velocity. So for the first problem, the velocity is 3, and we're going to try to determine the displacement. So displacement is literally just your final position relative to where you started, I guess. Is that right? Yeah, it's like it's the directed distance to where you started. So it's your total change. So if, for example, you wherever you are, right? If you move 3 feet to the right, your displacement is 3 feet to the right. If you go back to the beginning and you move 5 feet to the left, your displacement is 5 feet to the left. Like it's basically a vector, right? You have a magnitude and a direction. So 3 feet and to the right, or 10 feet to the left, or 15 feet behind, something like that. So displacements can be positive, they can be negative, and we want to talk about all that. So our velocity is 3 feet per second. And we're going to go for 3 feet per second. We're going to go for 10 seconds. So we want to know what's our displacement. Well, 3 feet per second times 10 seconds. So let's actually write that. So we have 3 feet per second, and then we're going to multiply that by 10 seconds. It's obviously going to give us 3 times 10 is 30 feet. But let's look at it more graphically, right? So with 3 feet per second, 10 seconds. So what we're really doing is we're really figuring out this area right here, right? 3 times 10. And then the units are going to be the units on the horizontal times the units on the vertical, right? Because I'm sorry, you start a thing and you just got to like finish it. Okay, so this is going to be in feet per second. This is in seconds. And if you multiply feet per second times seconds, you just get feet. So our displacement is 30 feet. What does that mean? 30 feet to the right of where you started. So if you remember when we did velocity and acceleration, we talked about, maybe we talked about that. Did we? We must have talked about displacement when we did that. Positive means you're either to the right or moving up. Negative means to the left or moving down, like conventionally. So let's see if we can do the next one. So this gave us 30 feet to the right of where we started. Here we have a -2, and we're going to go for 10 seconds. So we could calculate it like this. We could say -2 feet per second, and then times 10 seconds. So this seems weird, right? We're going to get -20 feet. And what does that mean in the context of what we're doing? It means that we are 20 feet to the left of where we started. 20 feet left of start. Well, let's look at it more geometrically again. So here, we're going to make, again, it's just a rectangle. And I'm going to use like a red color, I guess. Red-ish. this, and then if you do like around the edges, it's a little easier to color in. I don't know. I mean, if you're using Notability, little tip on how to use Notability to do that. So this, again, our y-axis is feet per second, and our horizontal is in seconds. When you multiply feet per second times seconds, you get feet. In this case, we're getting negative. So geometrically, how are we getting negative? We're getting negative because we're doing the area of a rectangle. This is a rectangle that has a base of 10 and a height of -2. So it's kind of a new idea. We can have negative heights, negative bases. It makes sense though, right? I mean, it's below the horizontal axis, so it should be negative. So we just have a base of 10 and a height of -2. That doesn't bother me at all. And I feel like it shouldn't bother you once you've done vectors a little bit in your life. Like negative things can definitely happen. So our displacement can be positive, it can be negative. It just depends on what the units are and what we're looking at. So let's see. I mean, these were easier because they're rectangles. So the new idea that we ran into is this concept of a signed area. So a signed area is an area that has a negative sign. I mean, because in general, you've also been using signed areas that were just always positive, but now sometimes they're going to be negative. So let's see if we can do this when it's not a rectangle and we're basically stuck using geometry, stuck, as if it's a terrible thing, kind of is. So let's see if we can work out our displacement here. So this is going to be in meters per second this time. So meters per second, which means this must be in seconds. And can we calculate it? So usually what you do is cut this up into like convenient blocks to work with. So for example, you might cut here, and you might cut here. You might actually cut more, and then maybe here. And then I think what a lot of people would do is probably also cut here. Probably. I don't know. It's kind of up to you. So am I gonna do that? I'm gonna not do that. And then we do some geometry, which is the most nerve-wracking part because it's embarrassing to get these wrong. But let's see. So this is gonna be 3 by 2. So this is 6. You actually do like literal counting boxes, right? 3 by 2, so that's 6. And then this is 3, well, it'd be 3 by 1. It's 3, but it's half of that. So 1.5 and 6 is 7.5. And then here we're gonna get 3. And then this is 3 by 2, but half of it. So 3. 3 plus 3 is 6. Is that right? How could that be? Oh, yeah. Okay. I think that's right. And then this is going to be half of 1 by 1, so just half, so 0.5. So our displacement is going to be 6 plus 7.5 plus 6 plus 0.5. Okay, 6.5, sure. Is, I don't know, 12, 19, I think 20. 20. And then the units are going to be meters per second times seconds is just meters. So should I check that again? I guess 12 and 8, yeah, 20. So 20 meters to the right of where you started. We don't know where you started. You could have started anywhere, but if after you started, wherever it is you started, this is your velocity, you're now 20 meters to the right. That's all it is. Oh no, there's a vertical axis. So instead of to the right, you're above. 20 meters above where you started, not to the right. So context, above. And it's all just geometry. So let's see if we can do this. So this is this one that we just did had a strictly positive velocity. The next one has a strictly, not strictly negative. It has a non-positive velocity because sometimes it's actually 0, like here and here. So this will have a non-positive velocity. Let's see if we can do it. So we're signed areas, right? They're all going to be negative because they all have negative some dimension, right? Heights, I guess. So I'm going to cut this up again. I'm going to cut it. Let's use a marker to do it. Cut it here. And, you know, maybe because this is a triangle. So I think I'll just treat that as one giant triangle. So here we're going to get 4 by -1. You can do it all positive and just make it negative at the end is one option. but 4 times -1 is -4, and then half of -4 is -2. So this overall is -6. This is, so you'll notice I'm mostly doing rectangles and halving them instead of thinking about triangles at all, which, I don't know, do what you want to do. This is half of -4, so -2. So this was not a triangle, so I couldn't deal with that as a triangle. This, on the other hand, though, is 4. So it has a base of 4 and base of 4, height of -3. That's -12, but half, so -6. -6. So our displacement will be -6, then another -2, then another -6. So -14. So that means wherever we started at the end, if this is our velocity, we're 14 meters below. So this was meters per second, and this is seconds. So you multiply meters per second and seconds, you get meters. We're 14 meters below because of the negative. So 14 meters below where we start. Okay, so this is going to be a really big idea. I'm going to stop here. All geometry and all just signed areas, which is kind of a new idea, but we're going to use this. So let's stop here, come back in the next video, do some more. So I will see you there.